Welcome back to our last lecture in CIT 130, Beginning Java. Today we are going to talk about reading from and writing to text files. What this lecture is going to do, in addition to allowing us to save data from our program into a file, is it's going to help us to reiterate a lot of object-oriented concepts. Plus, we're going to see a way to use the string array args that we've had as the input to the main method throughout the entire semester. It's something we've never used, but this is an ideal example for showing a way that we can use that. So it allows us to kind of see the final piece from the very first example program we did, all the pieces, parts we have to put into our programs to do basic Java programming. We'll see the last one of those put into use as well. So in object-oriented programming, as we've kind of talked about it up to this point, we are dealing with creating objects from classes. And in general, those classes model real-world things. So one of the things that we're going to use in here today is a file class. We'll be supporting that with a few other classes as well, but being able to work with the file class is going to kind of reiterate or emphasize what it means to do object-oriented programming, where we work with a class that models something in the real world. Let's go ahead and set our language to Java, as we've been doing all semester, and let's make a public class. We're going to call it invite people. We're going to create a program that allows us to invite people to an event or a party or something like that. We're going to, as we've done in all of our runnable applications, we're going to start with our public static void main string array args. Now, by this point, you understand that public allows it to be accessed from outside of the class or objects of the class. The static means it's part of this class invite people, but no invite people objects, because the runnable program, we never make objects out of it. That's why we have to make the main static void. If you remember, it means that this returns nothing. It's called main so that the virtual machine knows where to start. And we'll play around with the string args in a little bit today, so we'll see a way we can use that. Let's start by declaring a variable, or an object, a reference variable for an object. We're going to make a file, and we're going to call that invitees. So it's going to be a folder that will hold the people we are inviting to our party in it. We'll go ahead, we're going to create another object, and it is going to be a file writer, and we'll talk about what that is in a little bit. We're going to call that append mode, and then we're going to make something called a print writer that we are going to call output stream, and those are going to be our initial objects. As you might imagine, this is going to require an import statement. Remember, the import statement allows us to make dynamic references to classes in specific libraries. I am going to use stuff from the java.io library. I'm going to use the star to indicate I want access to every class in there, because we are going to make use of uh, the file writer, and the print writer classes, and the IO exception. So we will be doing some exception handling, and we're going to be using a type of exception called an IO exception. So that gives us access to these three objects we just created. So what we're going to do to start out here is we are going to instantiate our file called invitees. I'm separating the instantiation from the declaration because we're going to add to this program throughout today's lecture, and I'm going to do some things where I allow the user to decide what the file is going to be called and things like that, but we still always want to maintain that best practice of declaring our variables at the top of the method. So invitees is going to be a new file, and what we're going to do is we are going to do C:\, \users, \Brian, \desktop, \people.text. I did it the first time, but I didn't the others. We want to put // in there, because if you remember when we worked with those escape characters like the \n and the \t way back at the beginning of the semester, remember if the slash is followed by, whatever the slash is followed by is an escape character. So for instance, if I had just /Brian, it would think I meant a backspace /b followed by the characters RIAN. When we do \\, what I'm essentially doing is escaping the backslash so that \\, prints out a single backslash. That sounds kind of tongue twistery or kind of funny, but really it's just a way of showing that we actually mean the character backslash rather than an escape character. So now what we've done is we've selected a file, and now what we're going to do first is we're going to write to the file, because it doesn't make any sense to read from a file if there's nothing in it. So when we want to write to or read from a file, we have to use another kind of object that is sort of the pipeline between the program and the file itself. When we write to that file, that pipeline is an output pipeline, or what we call an output stream. And when we read from the file, it's an input pipeline or an input stream of some sort. So one way we can do this is print writer. Whoops. I already declared it. We want to do output stream equals new print writer invitees, where we can specify the file we're writing to. If we go out to our Java documentation, we go to the Java I/O library, and we look up our print writer, what we're going to find is, just as I used it, that there's a constructor where we can specifically designate a file. When we do that, however, when we create a print writer to a specified file, what we're doing is automatically overwriting what's in the file every time. So we can't decide whether this is a save or a save as kind of option. Are we adding to, or are we obliterating the content? So I always use an intermediary. The file writer class allows me to put in what I like to call like a bouncer in between the output stream and the file. When we make append mode a new file writer and we send it the file, and then an append mode, true means we want to append, false means we want to overwrite, then we have some say as to how we're going to write to the file. So we've put that in there as sort of a moderator between the output stream, which just sends data, and the file, which is going to receive it. What I can do here now is I can put the append mode in the print writer instead of the file. If we go back, we'll see that one of the options we have is sending a writer. Here's a little peek at what you're going to see next semester if you join us for Advanced Java. Is we see under file writer here that in this little sort of stacked list, that writer is above file writer. If that's the case, we say that file writer inherits from writer, and therefore a file writer is also a writer. Again, come next semester, and you'll get an opportunity not only to learn a lot about inheritance, but to practice it and do some really fun and neat things with that concept. But what we're basically doing is we're sending that file writer instead of the file to the print writer, so that the output stream has to go through that moderator or that bouncer to get to the file, so we can decide whether we append or overwrite. So now that we have that architecture set up, three objects: a file, and a file represents something in real life. We're actually going to see this in use. When we run this program in just a couple of minutes, we're going to actually see that this file object is going to correspond to an actual file on this computer. Then we have a little bit more abstract object, the append mode. But like I said, think of it as a moderator between the data stream and the file itself. The data stream is going to take data from our program and feed it into the file through the moderator. The moderator stands in front of the file and determines whether we append or we overwrite. In this case, we're overwriting. So now let's allow the user to write some stuff to the file. Let's do system.out.print, and we'll say who is being invited to the event. And I'm going to add an instruction here. I'm going to tell them to enter 0 to quit entering guests. This is a concept we talk about in programming called like a sentinel value. We use some kind of value that would never make sense as a regular input to be the exit value, so that the user knows how to tell the program, I am finished, without having to ask every time you enter in a guest, are you done? Instead, with the sentinel value, we have like an exit value that allows them to just to keep typing in names until they're done, and then they can type in this special value, which really shouldn't correspond to anyone's real name. And what we're going to do here is we are going to take the next invitee from the keyboard, and we'll do the next line so that we can take the name, it can have spaces in it, all that stuff, and then when they hit return, it takes that all, including the return, and feeds it into the file. Now, as you imagine, you're telling yourself as you're watching this, is that means I need to import java.util.scanner, as we learned way back in the second lecture. And we need to create our keyboard object, which is a new scanner system.in. And going back to our lecture on static members, in is a static member that represents the keyboard. It's a static member of the system class, just as the system.out is a static object that represents the console for displaying messages to. So now I should be able to take that next line, and since we're storing it somewhere, so let's declare that variable. We'll have a string name. So basically, now that we've asked them to put somebody in, they're going to put that person in, and we're going to store their name. And what we're going to do is if it's not the case that name equals 0, and remember from our lecture on strings and such, a string is an object, and normally we use the dot equals with objects because we want to compare if the two objects are equivalent, as opposed to whether or not they're both references to the exact same object. Now what we can do is on the output, the output stream, which is our print writer. So we're going to send data into that stream from our program towards the file, but through the moderator. And what's really cool is the output stream, which system.in is also an output stream. We have the ability to use the same, the system.out is what I meant rather than system.in. We have the ability in those output streams to use the same print method. So I can say I want a print line name. So what I've done is I've taken everything they just typed in and hit enter as a string, and I fed that string as is with the carriage return into my data pipeline, my output stream. That piece of data goes down, it hits the append mode, which says false. So had there been data in the file, it goes ahead and replaces it with this first element. What we're doing is we're overwriting what's in the file with our new data. And if the file did not exist before, this process will create the file. So that'll allow us to enter in names until we enter in a 0. And we'll do this whole operation while not name dot equals 0. So as long as they don't enter a 0, it'll keep allowing us to enter names. It is then customary for us to close the output stream. We want to close the file so that it can be opened with another program to be read, or even within the same program. We just want to make sure that we don't leave that file in an open state. We instead close that file. So again, we've created a series of 5 objects. We're familiar. We've been using this keyboard object for a long time. And remember, it doesn't have to be called keyboard. We just use a name that's descriptive of what it is. System.in is that static object that's an input stream representing the keyboard. When we give it the scanner, everything that's typed in the keyboard before a return is hit is pulled, is read using the sort of the next series of commands. We have the file, which represents the file we're writing to, the append mode, which is a moderator, which decides whether we're appending or overwriting, and we have the data stream, which takes the data from the program and pushes it towards the file through the file writer. Hopefully this is relatively straightforward. This is going to be the basic building block, and we'll save it. Fall 2019, CIT 130, examples. Remembering, as this we're kind of doing review as we do the rest of this, we're going to need to save it under the same name as the class itself, invite people.java. We'll save that, and then we'll go out here, and we will compile it. And what we see here is we see unreported exception, IO exception, must be caught or declared to be thrown. This goes back to that concept I talked about in the exceptions lecture of checked versus unchecked exceptions. The IO exception is a checked exception. So, in order to create our new file writer, we have to make sure that we're prepared to catch an IO exception. So what we'll do is we'll set up our try block. We'll indent everything, close that try block, and we will catch IO exception, and by convention we always name our exceptions the capital letters from the exception, IOE, and we will print out some kind of message, we'll just say system.out.println, no such file, like if there's some kind of issue creating the file of some sort. So we'll say no such file, create that as an error, and we'll display that for the user, and we'll know that there's something happened with creating the new file to write to. So again, because IO exception is a checked exception that can be thrown clearly by the constructor for the file writer, and if we want to verify that, we look in here and we look at the file writer, where it takes in a file name and an append, and we see here that an IO exception can be thrown if the named file exists but is a directory rather than a regular file, or does not exist and cannot be created, or it cannot be opened for another reason, like it was opened earlier in the program and was never closed, something like that. That is when we can have a problem. So what we're doing is we're catching that. And the reason that the designer of the file writer constructor built it that way is specifically because they wanted to make sure that we handled the situation where the file can't be built. So let's recompile, and now hopefully we get no problems, and we can run the program, and we can see who's being invited to the event. We'll invite Joe Blow. We will invite Jim Dandy. We will invite John Smith. We will invite Jane Doe. And then we'll put the 0, because it tells us enter 0 to quit entering guests. When we hit that, that finishes the work. When we go out here, we see that the file people that we mentioned over here now exists. And we'll even see that it was created 1 minute ago, which is when we ran this, when we ran the program. And when I open it up, it has the people that I wrote into it. I exit, and remember, append mode is false. So let's see, what does that mean? What does that do when I rerun Java invite people? Let's say I invite a different set of people. Let's say I invite Jackson and Elise and Margaret and John and Leslie and Tom. And that's it. And I hit 0, and it worked. Let's open up that people file again. And look, my old set of people are now gone, and the new set of people are in there, because my append mode is false. So what I'm doing is I'm overwriting. So let's instead change it, the append mode, to true. And we're going to do, in addition to that, which is going to show, remember I had those sets of people in there, they're going to stay in there because I'm going to go into append mode now. But let's add another operation in here. Let's read back from the file right here inside of our program. I'm going to add a new object. this object is going to be a scanner, and that scanner is going to be called input stream, because this is going to be the data stream for reading the file. When we wrote the file, we called it output stream. When we're reading from the file, we're going to call it input stream. Let's go down here and let's instantiate it. Let's say input stream equals new scanner invitees. So we are going to work with the same file we worked with before. Now, one of the things we want to look at here, or I want to show you more specifically, if I go to java.util to the scanner, which we've been using with the keyboard, when we look at the constructors for a scanner, one of the choices is a file, and if we look there, we have a file not found exception. So what we might want to do is catch that separately. Now, one of the things I want to show you, this is another peek at that inheritance idea, it's a little other new learning, is we see that file not found exception is underneath IO exception. We're already looking at IO exception. If we want to handle a file not found differently than the other IO exception for when we cannot create the file, we have to catch that. We have to catch the file not found first, because a file not found exception is also an IO exception, which means that my catch for IO exception will handle both. When I put this generic message in here, no such file, that works for both. But just to kind of show something a little bit new, let's add in a file not found exception, FNFE, and let's do the system.out.println. That file does not exist. And down here, we'll make this a little more specific and say something like problem creating the new file. Now again, because file not found exception inherits from IO exception, we have to put it first, otherwise the larger net catches it. When an exception is thrown, the first catch that matches is the one that will handle the problem. So now we've created the input stream to read from the file. We don't need any kind of moderator here because reading is reading. When we read from the file, we just read from the file. We're going to use a while loop, while input stream dot has next. This is a method of the scanner we haven't used before. If we go back to our scanner, I think we were there immediately before, we'll see that there is, let me go back to the top, you'll see that there is a method here called hasNext that returns true if there's more tokens in the stream. in this case, the file. If there's more output in the file, if we haven't reached end of file, then what we're going to do is we are going to system.out.println. I'm sorry, let's do a printf, and we'll say %s has been invited %n, comma, input stream dot next line. The thing that's cool here about us being able to use the scanner with files as we do with the keyboard is we're using the same methods. The next line is just going to read the next token, including the carriage return, pop it in here, and say, Jackson has been invited, etc., etc. It'll just go through each of these and print them out. So all we had to do to read from the file is create a new scanner object, and this shows that cool object-oriented idea where keyboard is an object of type scanner, input stream is an object of type scanner, keyboard is attached to the system.in input stream, which is a static object representing the keyboard. This input stream is attached to a file so that we can read data out of the file. So whether we read from the keyboard or a file, which we do down here when we instantiate it, or the file, they're both scanners which allow us to read data from an input stream, either a file or the keyboard in this case. So they're very different, and we can operate on them by reading people off the keyboard up here, or reading people out of the file down here. So we have two different places where we can pull data out of the file. So, or out of input streams, one being the file, one being the keyboard. Remember, we now changed our input, our append mode to true, so the people I added before aren't going to change. So Jackson, Elise, Margaret, John, Leslie, and Tom, when I recompile, they still exist in the file. Let me go ahead and add my semicolon I missed. Compile again. Let's run it. And let's say we're going to add in Chris, Amy, Barry, and Nicole. We hit 0, and now, remember, we closed the file so that we could open it for reading, and we looked at Jackson, Elise, Margaret, John, Leslie, Tom, and the new ones, Chris, Amy, Barry, Nicole. Now, interestingly, one of the things we can do here that may or may not be obvious is, let me go into people here. This is just a text file. This text file essentially has nothing to do with Java. So if I go in here and I add in Dave and Dawn, just add them into the file like I would any other text file. I save and I close, and I rerun the program. Let me just put in 0 so I'm not adding anybody new. What we'll see is when it reads back in from the file, Dave and Dawn are in that list. So what I've done is I'm still reading from that file. That file is, there's nothing special about it that it has to be accessed through the program. It is just a text file. So when I added 2 names to it, those names become output when I read from that file. So this truly is just a plain text file. There's nothing magical about it in terms of text files in general. So now we've successfully written to a file. We've read from the same file. I want to add in one more thing in here in today's lecture. What I want to do is I want to take advantage of this string args thing. What this refers to is arguments that are sent to the actual program itself. When we run the main from the Java virtual machine, anything that follows the name of the class after spaces are added to a string array called args. When we run it as we have been, with nothing after the class name, that array is size 0 and is empty. But let's see what happens if we put something in there and we want to look at it. I'm going to create an if statement. I'm going to say if args sub 0 equals dash question mark. I'm going to add some instructions. Dash question mark is going to be an argument to indicate, hey, I want to know how to use this program. So I'm going to do a system.out.println. And I'm going to say, put the fully qualified path and file name first. And then I'm going to put designate escape quote means print it out as a quotation mark rather than end the string. True/quote. For append mode to the file, comma, false. Oops, I don't want spaces, I just want the quotes. For overwrite mode. And then let's give them an example to see what that is. And we'll say example Java invite people space. And then we want the fully qualified path. Let's just take the one that we hard-coded up here. Put it there. And then we'll put the word true for append mode, so that they see that I do Java invite people. Now again, going back to the idea of the system.args, this first thing is treated as the 0th element, the first element, or at the 0th index in that string array. That is arg sub 0. This true would be arg sub 1, or the first element in the array. In order for them to know that that's what we want, we're saying that if they type in dash question mark, that if that's what's at the 0th element, so if they type in Java invite people space dash question mark, it's going to print out this message. Let's show that real quick. Let's see that in action. I have to recompile it because I added some new code. Oop, I left out a semicolon somewhere. Been doing that a lot today. Let's compile it. And let's run it. One of the things we get here, I didn't put any argument there. I didn't put that dash question mark. So I got an array out of bounds exception. I didn't get it when didn't tell me about it when I compiled, which means array out of bounds is unchecked. But I don't want it to crash if the person doesn't put anything in there. What I want to do is I want to add a catch array out of bounds exception, AIOOBE, and the array out of bounds exception is not an IO exception or a file of not found exception. It doesn't inherit from those, so we can put it last. We're fine there. What we'll put here is we'll say improper use type Java invite people dash question mark to see how to properly run the program, close. So we'll give them an error if they run it with no argument to see that they got to do something. Let's recompile one more time. And we run it, Java invite people. And now what it says is improper use Java invite people. You type Java invite people dash question mark to see how to properly run the program. Oh, now I see. Put the fully qualified path and file name first. Designate true for append mode to the file, false for overwrite mode. Example, Java invite people, C, Now, I haven't written the part to handle if they use it correctly, just if they put in the question mark or if they mess it up altogether. So, but no, the key here is that everything you put separated by spaces is going to go into this array called args. So when I didn't send any arguments, I couldn't read args sub 0 because args was 0 length. Because we're in the try block, and remember I said in the exception lecture, we can have multiple operations that can throw exceptions as long as we have the catch statements at the end. Here, when we don't put any argument, it catches it at the back end, improper use, so that they can see, and if they type in the dash question mark, they get this. So now what I want to do is if they do it, if they type it in, now if they use it properly, what we can do is instead of creating the new file as that, I'm going to move this above, because if they put in the dash question mark, that's just finding out how to do it. So if they do it correctly now, instead of hard coding it, what I can do is I can say args sub 0. Because if they do it the way it was shown here, args sub 0 is going to be like whatever they typed in. And they're going to type it in with a single slash. You'll see when it did the system.out print line, it showed it with single slashes. So they're going to know how to use it properly. So they only put in the single slash, but the virtual machine will handle it from there. It takes it in as a string, knows how to escape those properly. And so now we're going to use args sub 0 as our file name. And in what we can do here is after that, let's say if args dot length is greater than 1, this one here will be args sub 1. But remember, args sub 1 is going to be a string, right? String array args. We have a wrapper class for Boolean. We did this with integer before. Boolean.parse Boolean args sub 1, which will now turn that argument into a Boolean. If it can't turn it into a Boolean, what we'll get is an input mismatch error. And if you didn't know that, remember this documentation, while at first seems a little daunting, really shares a lot of good information. If I go into the Boolean class and I look at the parse Boolean static method, that's why I called it through the class, takes in a string. Oh, this one actually doesn't. Most of the parses, like if I go to byte and parse byte, this is again why documentation is good. Same as you, I don't like to memorize. So this shows that it throws an exception if whatever came in can't be turned into a byte. That's not the case with Boolean. With our parse Boolean, what I'm going to guess is if it sees the word true, it makes it as true, and otherwise it just makes it false. Anything else is false. So we don't have to catch another exception. We'll leave that out. But again, there's the value of this documentation. This is why we have this, is it tells me how parse Boolean works. Rather than throw some kind of exception if they don't put in the word true or false, it just lets us set it to false if it's not the word true. And if I didn't check for this length here, what I'd get is I'd get the array out of bounds exception, but my message down below, yeah, it would work. But I'm just going to, that message would still say how to use it correctly. But just for the sake of seeing just some other ways of working with the end user, I could decide to instead do new file writer invitees and make it true. If they don't specify, then we'll default to append mode for the safety of the file. If the person forgets to put it in there, they're like, well, I gave the file, but I forgot to put the true or false. We'll make it true. That way we don't lose data when we do that. So now what I have done is I've allowed for the use of this program so that the person can determine for themselves what they want to call the file. So let's save it and recompile. Make sure I didn't make any mistakes as I was, talking through it with you. Let's run it. And, I messed it up. So let me do Java invite people question mark, just so you see that working too. Oh, that's showing it. Oh, but it says that file does not exist. What has happened here is it did this, but then it continued on inside the application. It did more stuff. So what it did was it tried to create a file with question mark, which isn't going to work. That's not a valid file name. What I can do is in here, I can add a call to the static method exit. The static method exit of the system class exits the program. When we send it 0, 0 indicates normal exiting. So if I go to java.lang and go to the system, we can look down here and we see that there is a terminate the current running Java virtual machine, and we can say status. It doesn't really tell us here that 0 is normal. We can look down here and see what this says. And really what it says is the argument serves as a status code. By convention, non-zero means abnormal. We're saying we exit normally because we just gave them a message and told them what's happening. And then we exit. That way, when we do this, and we see improper use, all is well, we do it with, we do it with the question mark, we don't get that extra file does not exist. It exited normally and didn't do any of the rest of these operations down here. So let's do it one more time. Java invite people c:\users\Brian\desktop /people.text, and let me leave the true or the false off. What we'll see is if I add another person like Lindsay, and then a 0, we get all the people we had before, and it added Lindsay, because if we didn't have a second argument, our length was only 1, it picked the file and then made it true for the append mode. If I added false on here, what's going to happen? Who's being invited? Now, if I just say Dan and Will and Chris and 0, we see the false made it overwrite mode. It cleared out the file and redid the stuff. But look, I can also go in here and make, let's say, instead of people, I call it invitees. And I make this one, whoops, I misspelled Jackson, Elise, Margaret. Let's just end with those. We see those three are there. And you'll see, when we go back out, there's two files here. There's that one, which I can correct my spelling if I wanted to. Because remember, we showed that I could touch the file, and people was left with the last set I did. Remember, it got overwritten when it had the big list, but now there's two files. I can choose to save whichever set of files I want to now, because I'm allowing arguments to the file. If I don't specify the fully qualified file, if, like, let's just say I didn't know any better or I wasn't paying attention, I just said invite people INV, and I just call it that, and I say false. And let's just go back to Joe Blow and Jane Doe and 0. It still works, but you'll see the file's not out here. The file for INV is in here. And you see it doesn't even have an extension on it. It's not a .txt or whatever. So, you know, I can open it with my Notepad++, and we see the people in there. When I didn't qualify it, it put it in the same directory as the running program. It put it where I was running from. That's what we see. And if I wind up putting, like, junk in here, you know, if this was like, you know, K less than P0, I get the system cannot find the file specified. That's actually coming from the operating system, I think, because I used the less than. Let me do something more like KP-9. Apparently the dash is fine as long as I didn't start with it. Sometimes it's hard to use gobbledygook. Dash JJJ. Oh, apparently that's a valid one as well. Maybe it was the one I used the question mark. It didn't. Let's go back to that. Let's do dash question mark file. We do that. That file does not exist, so we can't do anything with it. If I put in a real file name, like file name, but after that I put in, like, I don't know, remember that's going to set it as false. And we can do Joe and Jane and 0, and we get Joe and Jane back, and that's okay. We got, you see, it created all these files as we did them. And if we add extra stuff in, like more arguments, please, what's cool is none of that matters. Jack Pratt and wife. You see, remember, this defaulted to false, so it overwrote file name, which used to have Joe and Jane, now put in Jack Pratt and his wife, and it just ignored the rest of the arguments. It put them in the args array, but because our code doesn't look at that, doesn't matter. So that's the nice thing here, is we've really kind of set this up in a way that's pretty robust for the user. So just in a quick recap of what we did today is we added some classes and exceptions. This also had the file not found exception. And we worked with files, and we showed some object-oriented stuff, how we can have two different scanner objects that point at very, very different kinds of things. We created a scanner that works with a keyboard and a scanner that works with a file, but they're still scanner objects. As I showed below, they have even the same methods. I used print line. I'm sorry, that's the output. I used the next line with the file scanner, just like I do with it on the keyboard. I can use the same method in both places, even though they're very, very different made objects. We introduced some new objects, the file, which represents the file in the file system. The file writer, which is our moderator, decides whether we have append mode or not. And our print writer, which is the stream from which we connect the program to the file. And all output streams, whether they're system.out or this output stream that I create for a file, we can use the same things. We can use the print line, the printf. We have all those same methods. The class indicates what properties and methods it has, as we've been learning, but we can use them in very different ways. That's one of the things this shows. We also threw in this idea of the args array that is part of every main. We've just never used it. We allowed them to have a help mode. I could have made this dash help or dash H or whatever I wanted. I just made it dash question mark. And that prints out for them what they're supposed to do. If they didn't even know that much, remember, I can catch that with the array out of bounds exception. I could have looked that up, although remember, this is just a simple array. There's nothing special about args. It's just an array of strings. So if we try to access an index like 0 in an array that has no indexes because it's of length 0 or size 0, then it throws the array out of bounds exception. We tell them what to do. Otherwise, we use that first argument as a file name, which we told them that's what we wanted. We verify if they put a second one, because if they didn't, we default to append mode. But if they did, if they put the word true, it's append. Anything else is treated as false. Now that we've decided the file in the append mode, we create the output stream and attach it to the moderator, which is attached to the file. This is just like what we did earlier in the semester. Let them just put people in. And we're not really doing any data protection, as we don't care what people want to name themselves. If we want to invite Kesha with a $ for the S, or C3PO with letters and numbers in the name, we're open. As long as the name isn't just a single digit 0, we'll take in whatever they want as their name. Print them each on their own line inside the file. When they enter in that sentinel value, the 0, we close the file, it's all saved. And I showed you on the hard drive how it's saved. We then open up a scanner to the same file, and as long as there's data in the file, we grab the next line. And we'll keep grabbing the next line until there's no line to grab. When there's no line to grab, has next returns false, we drop out of the while loop. If the file started empty, we drop out of the loop. Even though, because of the way we wrote this, we have to specify the file and then write to it, so it'll never not exist. But in the weird case that the file didn't exist, we do have this file not found exception. That file does not exist. We also reiterated or reviewed some of this exception handling stuff. We introduced a little bit about checked and unchecked exceptions and inheritance to show why we need a file not found in front of IO exception. If that stuff was a little bit fuzzy for you, those are topics we cover again in the advanced class. So if you're joining us in the future for advanced Java, you'll get plenty of opportunity to look at and play with that. So I hope you enjoyed this lecture and that you enjoyed the class as a whole. I hope many of you will join us, if not next semester, at some point in the future in advanced Java, so that you can expand your knowledge and learn a lot more about the wonderful world of programming in Java. Take care.